If Enzo's weekly salary exceeds Celia's by $150 per week. All right, before you read the rest, who makes more? Enzo. Yeah, his salary is 150 more, right? Okay, so X is going to represent Celia's salary. Okay, how could I express Enzo's salary? If I knew Celia's was X, what's Enzo's? X plus 150, because it's 150 more, right? It's 100. It exceeds by 150. So this one's going to be X plus 150 would be Enzo's salary. Okay, so number 2, we have a telephone texting plan. It's got a monthly fee of $20. You pay that no matter what. And then you also pay 5 cents per text. All right, so we're going to write an expression that models the monthly cost for X text messages. So what do I do? Yes, $20 plus 5 cents every text. So you have to do 0.05 times the number of texts. All right, the width of a rectangle is represented by X, and the length is X plus 200. What is the rectangle's perimeter? Great, yes, that is correct, but we're going to simplify it. Yeah, so if I draw a picture, if they give you something that's drawable, if they're describing something that's drawable, you should draw it. Everybody ready? All right, so one side, the width is X, the length is X plus 200. And what's the perimeter of a rectangle? How do you figure it out? You would add all the sides together. So we would have X plus 200 plus X plus 200. And if I simplify that, I'm gonna get the name. Hold on. Amanda. Amanda said, I've got 2 X's and 2 X plus 200s. That's another way you could have written it. Simplifying that even further, I've got 4 X's, right? If I distribute the 2, and I've got 400. 4X plus 400 would be as simple as I could make it. All right, if you've got $3,000 to invest in 2 different accounts, one pays 2% and one pays 3.5%, but I don't really care about the interest rates at first, right? $3,000, 2 accounts, okay? If I put X in one of those accounts, I'm going to put X dollars in one of the accounts. How much do I put in the other account? 3,000 minus X, the rest, right? So you would just do 3,000, your total amount, minus the amount you put in the first account. So that's how much it goes in the second account. All right, so now I'm thinking about the interest. Okay, for part B, I want to think about how much interest I earn on the account that pays 3.5%. Okay. So first of all, how much money is in that account? 3,000 minus X, that's what we did in the first one. And then how do I figure out, like, what is 3.5% of 3,000 minus X? Times 0.035. So B is going to be 0.035 times the amount of money in the account. All right, last one. This one's kind of tricky. I heard a lot of good conversations about this one. Your local computer store is having a sale on digital cameras. After a 40% discount, the digital camera costs $276. What's the camera's price before the reduction? So it's really, really tempting to take 40% of 276. Why is that the wrong thing to do? Because what you took 40% of was the original price, and we don't know what that is. That's really tempting to do, but the thing that we took 40% of, we don't know what it is. We're on the right track. So let's write down all of our work here. We're saying let X be the original price. Okay, so everybody's, the things I've been hearing shouted out is like, oh, take 40% of X because that's the original price, right? So 40% of this is what? Is that the new price or the discount? That's the discount. So I have to take the original price, subtract 40% of the original price, and what do I get? 276. I get the sale price. What's 1x minus 0.4x? 0.6x. Which makes sense. If you get a 40% discount, if you're paying 40% less, then you're actually paying 60% of the original price. Right. Okay. So then you divide both sides by 0.6, and you get x is what? 460. Thank you. So it's a little bit tricky. I purposely was trying to trick you into taking 40% of the wrong number. Okay, so this section deals with models and applications. Many of you know these things as word problems. So that's why we spent the preview practicing writing expressions with variables in it. Let's start by looking at this bar graph. It shows average yearly earnings in the United States for people with a college education by the final degree earned, right? So a bachelor's degree average salary is somewhere between 50 and 60,000. If you have a master's degree, the average salary is somewhere between 60 and 70. If you get a doctorate degree, it's a little more than 70, and a professional degree, around 80. I imagine that would be like a medical doctor or a lawyer, or a doctorate is usually referring to a PhD. An MD is a professional degree. Yeah, for like a specific profession. An MD, law school. Yeah. What else would be a professional? Like maybe a nursing degree, veterinarian, yeah, things like that. Dentist. Sorry. Professional. Yeah. Okay, so the average yearly salary of an American whose final degree is a master's degree is $49,000 less than twice that of an American whose final degree is a bachelor's. Combined, two people with each of these educational attainments earn $116,000. We want to find the average salary for an American for each of these final degrees. All right, so we have an estimate. We can estimate from the table, right? But if I wanted to know exactly, where would I begin? What would I do? Before you start writing down expressions, what do you have to do? Define your variable. That should always be a first step. Okay, so if we go to the next page here, we're going to walk through it in a step-by-step way here. So, first strategy, read the problem carefully. Identify or describe in words the quantity or quantities, numerical values you're being asked to find. Okay, so figure out what you're being asked. That's the very first thing. Scan through that question till you find the question, right? Not all the information that's given, but the question. Where does the thing we're being asked to find? There's the question. Okay. So let's have, say, X be the salary for what two degrees are we thinking about? Bachelor's and master's. So which one do you want X to be? Master's. Okay, so X will be the salary for a master's degree. And then how could I, oh, so, yeah, sorry, I did that in the wrong box there. X is the master's degree. All right. So the thing I'm being asked to find is salary for a master's degree, salary for bachelor's, right? All right, so then I have to assign a variable. You could pick X or any other letter you want to represent one of the unknown quantities. Okay. So how do we decide which one? You told me to let X be the master's degree. Does it matter in this case? No, because they asked us to find both things. I tend to define X so that when I'm done solving, X is the answer to their question. But in this case, I have to find both things, so it doesn't matter. So we'll just pick randomly salary for the master's degree. All right. Then I have to write all the other unknown quantities in terms of X. So I have to come up with an expression for the bachelor's degree salary. So I'm going to have to sort of dig into the question a little bit to try to find out how are these two salaries related to each other. Yeah, so many of you are using the first sentence just fine, but what if you use the second sentence? Yeah, the two salaries together have to add up to 116,000. So if the master's degree is X, then the bachelor's degree is 116,000 minus X. And I'm just going to measure everything in thousands. So I didn't write out the 000 after the 116. When I'm done solving, I'll just know that that number is measured in thousands. Oh, I meant to write that in the box below. Sorry. All right, now we have to come up with an equation. What equals what, right? So I have used the last sentence to identify my variables. I used the second to last sentence to write an expression for the other unknown quantity. The only thing I have left is the first sentence. Hopefully the first sentence will help me write an equation. What equals what? That's okay. It's a good. Yeah, it's a good start. 49,000 less than something, so it's minus 49,000. So if no, this is just an expression for the salary for the bachelor's degree. All right, so an American whose final degree is a master's, right? So what represents the X? Okay, is, right? This is equals. So an American whose final degree is a master's, we define that as X, right? So X is, right? X is, and then 49,000 less than twice that of a bachelor's. What expression represents a bachelor's? 116 minus X, that's the salary of a bachelor's. Double it, less 49,000. Yeah.
For example, write it a different way, like 2x minus 49,000.
116 minus x. Yes. Yes, if that was your equation, that just means that you defined your variables differently. You wrote x equals the salary for a bachelor's. Correct. Yep. It is your choice how to define the variable. So now we just solve the equation for x. So x equals 232 minus 2x minus 49. So add the 2x to both sides. 232 minus 49. Can anybody do that in their head? 232 minus 49 is 61,000? Yes. and then divide by 3. 61. 61. But then I should answer the question with a sentence, right? Write a sentence that answers the question. So if x is 61, what does that represent? Salary for a master's degree, $61,000. Okay, and then what's the salary for a bachelor's degree? 116 minus that. Yeah. $55,000. So then we should check our answer using the original wording of the problem, right? So we have 61 and 55 as the two salaries. Do they add up to 116,000? If you double the bachelor's salary, you get 110,000. And subtract 49, do you get 61? That was the first sentence. It said if you double the bachelor's degree salary and subtract 49, you're supposed to get the master's degree salary. And it does, it works, yeah. So they add up to 116, and 2 times 55 minus 49 does give you the 61. Check, check. All right, so just to preface, this takes practice. Defining variables, creating expressions for the other unknown quantities, it takes practice. So I'm going to let you start practicing right now.